Okay, so in this video we're going to solve the problem that's on the screen. So we're given some information about the first derivative. We're given the x values where the first derivative is equal to 0. So those would be our critical values. And we're just given the second derivative. No work in finding the second derivative. And so if we have the second derivative given and we're asked to find local maximum, local minimum, where those occur, second derivative test in this case is going to be easy because we've got the second derivative right in front of us. So the way that works is one by one you start plugging your critical values into the second derivative. So if we plug -2 into the second derivative, and we work that out. Let's see, it looks like when we plug -2 in, we get 0. Now remember, when the second derivative test comes out with a value of 0, when your second derivative comes out to be 0, you can't determine anything about whether that's a local max or a local min. So this is the one case where the test fails. Now that doesn't mean that we can't determine whether we've got a local min or a local max there. We just have to resort to other methods. And so we'll leave that one alone for right now. If we plug in 0 to our second derivative, let's see, things are always easy with 0. That would just be 0 plus 0 minus 4, which is -4. Now remember, your second derivative indicates information about the concavity of a graph. So this indicates that your graph is concave down. Concave down. And so if I have a local max or a local min, in order for it to be concave down, that would have to correspond to a local maximum. Right, so that tells me that I have a local max at this x value at x equals 0. And of course, you could go find the y value there, but I think the important information is that we know that that's a local max. And then if we plug the x value 1 into our second derivative, let's see, that's what, 4. It's just going to be 4 plus 9 minus 4, which is 9. Okay, so this being a positive number means that my graph is concave up. And if I've got a graph that's concave up, right, and I know I've got either a local max or a local min, in order for the graph to be concave up, it's got to be a local minimum at the x value 1. So we were able to get our answer for this critical value and for this critical value. We still don't have our answer for the critical value of x equals 2. Again, depending on exactly what the question says, you may or may not have to go back and find that, but the way that you could do that is you could use the first derivative. Actually, we'd use the first derivative test, in which case we would need to get the first derivative. Now, since we know the second derivative, since it's given, since we know the second derivative, we can get the first derivative by integrating once with respect to x. Going to integrate this guy with respect to x, and so if I do that, so do my antiderivative on each one of these terms, the x to the fourth plus 3x cubed minus 4x, of course, plus some constant, and I would need to know what that constant is, and I can figure it out because I've got several different pieces of information about the first derivative. I know that right, I was given the first derivative must be 0 when x is any of these values, right? So it doesn't matter which x value I use. 0 is always easy to work with. F prime of 0 is 0, and so if I apply that to my first derivative that I've found, let me give myself a little bit more space here so I have enough room to write this. F prime at 0, that means I'm going to put 0 in here, here, and here for x. So 0 plus 0 minus 0 plus c, that must be equal to 0. And so that tells me then that c must also be 0. So that tells me exactly what my first derivative is. It's just the antiderivative that I found here, and we now know that c is 0. What was it? X to the fourth, 3x cubed minus 4x. And now if I know the first derivative, I can apply my first derivative test, where I would make a sign chart. I would plot my critical values, which we knew were -2, 0, and 1. I really don't have to worry about doing anything with 0 and 1, because when I was working with my second derivative, I figured out what I have at 0 and at 1. The only question is what's going on here at 2. And the way that we do the second derivative test is we pick a value on the interval on either side of -2. So maybe we go with -3 here and -1 here. And then we need to plug those into our first derivative. So let's see, if I plug -3 in here, what's going to happen? I'm going to get -3 to the fourth, which is 81. I'm going to get -27 times 3, which is -81. And then this would be plus 12. That means my derivative is positive over here. Right, and then I would plug -1 into my first derivative. So that's going to give me 1 minus 3 plus 4, and that comes out to be also positive. So I've got a positive derivative on either side of this critical value, and what that means is that this is neither a relative max nor a relative min, right, since the sign of my derivative did not change. So I've got I've got one local max, one local min, and then neither at x equals -2. Neither a max nor a min.